So,
I just want to have a count of how many videos we start with so.
yeah.
Hashtag natural.
So last time we spoke about code on HTTP 203, we looked at tree shaking, like pipeline operator, the bind operator, like really future-facing stuff. But I thought this time we'll go and look at something that's been there forever or for a long time and how a feature has sort of developed over time. This. Now,
It's a for loop.
well done. You're still good at quizzes. Excellent.
1 point for me.
So I wanted to talk about how for loops actually work under the hood. Right.
You say actually as if there was like a big twist to the story.
Wow. Here's how it goes. So this bit runs, right?
Mm-hmm.
Yeah.
So it's like for loop has like 3 instructions, like the initializer, the condition, and the incrementer or whatever. Or
Sure.
Iteration.
They're
code.
just expressions. So,
3 expressions, yeah.
So this one runs, then this one runs, and then the body runs, and then this one runs, and then this one runs, and then the body runs, and then this one runs, and this one runs, and the body runs, and this one runs, and this one. And it only stops if this bit evaluates to like something falsy.
Mm-hmm.
And that is how for loops work. But it has gotten more complicated in the past
I was about to
few
say, I
years.
haven't learned anything today.
Look, I mean, that was all correct. It is just that. Like, for loops
Yeah.
were really, really simple.
I mean, they've been in the oldest programming language in exactly this format with these 3 statements that get evaluated in that specific order over and over.
Let's have a look at this. What is going to be logged in this piece of code?
What we have in here, which is kind of hidden, is a closure, right? So
Yes.
we're
Yes, so
passing
this
a
is
closure to set time and saying execute this closure in
some amount of time.
this time. Apparently, it's 0 milliseconds, I think.
It would default to 0. The browser will add a padding
4,
to it.
yeah.
4, 15. The browser's allowed to do whatever. So, the key is that this is going to happen asynchronously after the for loop is
So we'll
completed.
close over the I variable, which in this case is a primitive value. And therefore, the value will be captured. So this would mean that we will see 3 logs, 0, 1, and 2.
Not quite. There is only one I in this story.
Interesting.
And that's going to be scoped to the parent function or the global scope if there's no parent function.
Oh, right. Yeah.
So when we increment it, and increment it
It
again.
will be evaluated at when the closure is being executed. So that's actually when it looks up the value.
Exactly.
I see.
So we're going to get console log of 2 twice.
3 times. Twice. For loops.
We're professional developers. I had to stare at that as well. And I ran this code earlier, but maybe, I don't know.
I just lost all my credibility.
It's OK. You've got time to regain it. Here we go. But, dun, dun, dun.
OK.
Things have changed.
So intuitively, I would think and hope that it wouldn't change anything. But I'm guessing you set this up in a way that it actually does.
Things have changed.
So I mean, I think you hinted at it because you said that previously the I was declared as a var, meaning it is being declared within the function scope, which if there's nothing outside of this would be the global scope.
Yes. So let's take a look at this. So what we have here is like an if true. So this block is always going to run, and we're declaring in there like we've got a var, a const, and a let, sort of logging them all out. The var is scoped to the parent function or the global scope, whereas const and let are, I think the term is lexically scoped.
To the block.
To the block. Right. So what happens here with these console logs, this first one works. It will log 1.
Yeah.
But what we hit here with this console log in a const and in a let is that's going to throw.
Yeah.
Because it has no access to those. They are scoped within there. And like you say, it's all blocks. And a lot of folks don't seem to know this, but yeah, you can just have a bare block like that. I actually find that really useful.
It can be. I have used it since const and let. I have used that every now and then to just declare that this variable is just needed for these 3 instructions. And then
especially if you've got like a global, if you're doing some inline script in a script tag, I just wrap it in these to make sure
or you
that
want to
those
shadow
aren't
something just for a specific number of lines.
Exactly that. Yes, that's what I've used it for. So back to this example. So you're saying same as var? Is that?
So now that we have caught up on that, the question now is, the let is technically, like, I want to say geographically, the let is outside of the block.
Yeah.
But is it, though?
But
because
is it, though?
it is a for statement. So I actually, my intuition would still be it should work the same. But I would also understand if it didn't. But I don't know what the answer is.
The ECMAScript spec actually special cases this.
OK.
This situation. So I agree with you. Like geographically, this let statement looks like it's outside the block of the for, but it does magic tricks. And this is where like for loops are just like, oh, this thing that was really simple before is now actually really complicated. So what you will actually get here is a console log of 0 and 1.
Interesting.
It creates a lexical scope for each iteration.
So it's literally a new I. It's not just the same variable assigned a new value. It's a new variable.
It is, yes, it is a new variable.
Wow.
And there's a lot of trickery in here. And this exposes some interesting behaviors I'd never really thought about before, about how for loops suspect. And one of them is like, so this plus plus at the end, the incrementer, I always thought of that as being at the end of a for loop iteration. Like, so, you know, do this, do that, and then.
Well, that wouldn't work if it's a new variable, right?
Well, this is.
I guess it could.
Well, because this logs 0 rather than 1, we know that this is not happening as part of that same iteration. And what actually happens is this.
No, it could be just after the body, right? It could be still.
Well, no, because then this is a closure, so this is being logged.
Oh, you're right. Yeah.
And so this is the weird thing. It's like it exposes that the incrementer runs at the start of every iteration except the first one. I know, right? This is.
Throw all the elegance out of the window.
So the way it actually works. Well, actually, let's introduce like an extra thing.
So now the question is, does it copy like the value at the end of the body to the first value of the next iteration and then apply the?
Yeah, I think you've got your credibility back because that is exactly what it does.
Ooh.
Yes.
I mean, it would have to because if you go back to var land, it would
behave like that.
Yeah.
You can alter the value of I within. Yeah. So what happens is it does this like bit, this special bit that it treats as a declaration. It records all of the things that are set. It sort of has some bookkeeping there of like.
Really?
So in this case, it's like I, just I. But you could declare many. It runs its check here.
Cool.
And then so it actually creates a new lexical environment before it runs this check. And it copies the value of I into it.
Because that check can actually be side effecty, right?
It
can be all kind of stupid thing.
It can all be side effecty, which is the amazing thing. So then it runs the body in that same lexical environment that we did this bit. So we've got our set timeout. We're logging. So at this point, I is 0. We're queuing our task. Then we're doing I++. So this is where we're mutating I to be 1.
Yeah.
And then that's the end of that lexical environment, because it then creates a new lexical environment to do the next iteration, which begins with this. And yes, you're right, it copies the value from one into the other. For everything listed in this section, it copies a value. So now it's taking I, which is 1, into the new lexical environment. We do our plus plus on it. I is now 2. We do our check. It is not less than 2. So
and we get a log of 1.
And we get a log of 1.
Even though we incremented after scheduling the task.
Yes, because it's still pointing at that instance of 1 that we
So just for the record, for the people at home, don't.
No.
That is, like, if you have to know these intricacies, if your code relies on these intricacies, most likely it's a bad idea, right?
Well, I would say that this is actually pretty intuitive, because as you say, it works a lot like var did, but it's doing so many like jumping over hoops.
I mean, I would have said the same thing about var. If you rely on, I mean, this is kind of out of order then, right? Like you do things to a variable that's already been used beforehand, and you rely on the value. These things, while possible, don't use them any way to avoid it.
Yeah, if you can use async await rather than something like this, your code's a lot more sensible. But yeah, so the copying between stuff only happens with things declared there. So if you have sort of another variable in there, it is not copying that between the executing context, because it's not one of the ones declared.
Okay,
it's got this special thing where it deals with that.
So does const behave any different?
Well, so if you can actually put const there.
Yeah, I know.
But then it will fail as soon as this happens.
Oh, really?
Well, it's constant. You can't reassign to it.
I mean, if it's a new variable every time, I don't know.
Well, no, because it creates the new variable, and then you are executing this, so that's when the mutation happens.
OK.
So it is odd that the spec does sort of allow that to happen, but it will only ever work.
I mean, it could still be a valid for loop if you have no code in your incrementer bit, right?
So the spec still has to deal with it. So, final one.
If you format your code like this, I'm going to slap you.
The reason is because I'm going to do this.
Why?
So what? OK, so I'm jumping through some hoops here. All I'm doing is I'm assigning 0 to I. But I'm just using this statement so I can stuff like a set timeout.
Oh, I miscounted the parentheses. I was like, wait, you're storing the timeout ID in I, but it's not.
No, there's a lot of parentheses.
So this is another thing that people not necessarily know, that you can, if you want to concatenate commands in JavaScript, you can use and, you can use a semicolon, and you can use a comma. They all have slightly different meanings in how they concatenate and when they abort to concatenate. But
yeah, that's right. I could have used and here. I didn't think about that. But
just calling it out. So this is not a function parameter comma. This is a concatenating two individual expressions comma.
Yes, because I can't use semicolon because that's part of the for loop stuff.
I mean, you could have used an anonymous function that you immediately evaluate.
Look, I would have had to make the font even smaller to do that. So, you've talked around some of the problem. So my question is, what is going to be logged here? So I've got my I++ here. You've got your I++ there. What do you think?
I just want to leave.
Do you know what? I didn't know this until I looked at the spec.
OK.
Because I wanted to talk about the complication behind a for loop, and I only discovered this particular thing.
So what I kind of assume is that this parentheses expressions, which is the set timeout and the return 0 in a way, that is being assigned to I once at the start, right?
But this I it's going. So this call here is going to be referring to this.
You just asked me what do I think. What is the actual question? Like the for loop the body should run once, right?
The question comes down to which lexical scope is this code going to be running in? Like we sort of said, there are many within a for loop, but so what possible mutations are going to happen to I before this code runs? Because this for loop is going to run to completion.
I mean, this is a task. This will run after the for loop is done because for loop is synchronous. So technically, you said this I++ is creating a new lexical scope, but does it mean it's referring to a different variable now or not?
I'm having so much fun.
I'm going to say it logs a 1.
Logs a 1, and that is what I would have said as well. But it is not correct. No, seriously. So here's the weird thing. It creates an additional lexical scope for this initial statement of a for loop.
OK.
So it creates a lexical scope, runs this line, and once it's run that, it goes, well, what are the values of everything declared? And then it copies them into a new lexical scope to do the rest of the for loop, to do this and then
so it will log a 0.
Because it never hits any of these mutation points. And it's really weird. So you get so many lexical scopes in just a simple for loop.
So basically what we're saying is don't use for loops. Is that our general advice?
No, use for of. That's so much simpler. That's the story. You don't have to worry about any of this. Just use iterators and for of. So I've essentially just wasted everyone's time.
Well done. Welcome to HTTP 203. We're back.
Maybe we should be one of those podcasts that has a little jingle between.
Yeah, we need transition jingles.
Welcome back, listeners. We were talking about lasers, but we're now going to pick up on.
Today we're sponsored by Google Micro Kitchen.
Sponsored by Google Chrome again. Oh.
Please do it.
Download Chrome, everyone.